Hey guys, this video is about percent composition. All right. All right. So now, what does the percent composition of a compound tell you? Well, inside shirts or pants or clothes, there's these little tags that tell you what the product is made of. Okay. In this case here, you have 85% cotton, 15% polyester. Okay. Now, there are shirts that are 100% cotton, 95% cotton with 5% polyester. Okay, well, polyester is essentially like a plastic that's mixed with the cotton to give it some strength, flexibility, and to prolong the shirt's life. Okay, but anyway, let's look a little deeper. How do you calculate the percent composition of a compound? Well, we're going to go over two parts to percent composition, and there's a lot more that you could do with percent composition, but we're going to keep it basic. All right, when you get to college, there's going to be a lot more problem solving utilizing this, especially in forensics and whatnot. Okay, the relative amounts of the elements in a compound are expressed as the percent composition, or the percent by mass of each element in the compound. Okay, so let's take a look at this formula right here. The percent composition of potassium chromate, K2CrO4, is 40.3% potassium, 26.8% chromium, and 32.9% oxygen. Okay, how do we find out those numbers? Well, there was a little bit of math involved using this, and you have to use your periodic table. You need to know their mass numbers. Okay. Now, the percents should equal 100% if done correctly. That's a clue to you that you're aware of if you did the problem correct or not. All right. So if you look right here, K2CrO4 and K2C2O7, potassium chromate, potassium dichromate, they both have the sum of 100%. Okay, two different formulas, they both have the sum of 100%. Okay, let's look at part one, this type of solving problems with percent composition. Okay, now percent composition from mass data. If you know the relative masses of each element in a compound, you can calculate the percent composition of the compound. Okay, the percent by mass of an element in a compound is the number of grams of the element divided by the mass in grams of the compound multiplied by 100%. This is almost like part over whole that you learn in math. Okay, now let's take a look at this problem here. When a 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.40 grams of oxygen is obtained. What is the percent composition of this compound? Okay, first off, let's look at what we're given. We're given a sample that has magnesium and oxygen in it, which is 13.6 grams. However, they only give you the mass of oxygen, which is 5.40. Oh no, what do? Well, we have to find the mass of magnesium. Okay, so we need to use both these numbers. So what we have to do is the percent by mass of an element in a compound is the mass of that element divided by the mass of the compound multiplied by 100%. Okay, so the mass of the compound is 13.60. Mass of oxygen is 5.40. So mass of magnesium is simply subtracting these two masses and you get 8.20. Okay, so let's calculate the mass of each one of these. So it's simply taking the mass of the element, dividing it by the compound for each one of the elements. Okay, so for percent magnesium, mass of magnesium over the mass of compound times 100%, okay, is 8.2 divided by 13 times 100% is 60.3. It's actually times 100. Don't hit the percent key. Okay. Now for oxygen, it's the mass of oxygen, 5.40, divided by 13.6 times 100, don't hit the percent key, and you get 39.7%. Okay? So the 2%, when you add them up, equal 100. This is a common problem that we run across on occasion, but it's a good practice problem. Now, part two deals with the moles. Okay? So let's kind of look through this really quick here. Percent composition from the chemical formula. Okay, you can also calculate the percent composition of a compound using its chemical formula. Okay, so without any given masses or anything, long as you have the correct formula or the name of the compound, and then you take the name and you write the formula. So as long as you have the correct written formula, the subscripts in the formula are used to calculate the mass of each element in a mole of that compound. Using the individual masses of the elements and the molar masses, you can calculate the percent, and I think the next line is cut off, by mass of each element. Okay. So you can see by mass of each element, this line was cut off, I believe. Okay, so let's move on. So here's the formula. Percent by mass of element. Mass of element in 1 mole of compound divided by the molar mass times 100. Okay, so we're going to look at propane. Propane is C3H8. There's 3 carbons, 8 hydrogens. The fuel commonly used in gas grills is one of the compounds contained from petroleum. Calculate the percent composition of propane. Okay, so what we have here is we have the mass of carbon and the mass of hydrogen in 1 mole of propane. So from the formula, we know there's 3 carbons or 3 moles. From the formula, there's 8 moles of hydrogen. Now, we will take the mass of each carbon, multiply it by the mass of each carbon. Okay, the mass is to 1 decimal place. Notice that? So we have 3 carbons times 12 grams is 36 grams. 8 hydrogens times the mass off the periodic table is 8 grams. So we take the sum of these two masses, and the molar mass of the compound is 44.0 grams. Okay, so now what we're going to do next is we're going to divide each one of these masses by 44, and that'll give you the percent mass for each one of those elements. So let's take a look. So the percent carbon is the mass of carbon in 1 mole of C3H8 divided by the molar mass of C3H8. Okay. Now we take our 36 divided by our 44 times 100, and we get 81.8% carbon. Now for hydrogen, the mass of hydrogen in 1 mole of C3H8, there's 8 hydrogens, okay? So there's 8 grams divided by 44, times it by 100, and we get 18%. Now, don't get confused. Some people get confused. Oh, 8 grams is not in 1H. You're right, it's not. There's 8 hydrogens, so there's 8 grams of hydrogens in 1 mole of C3H8, okay? The mass of 1 hydrogen is 1 gram, but there's 8 of them, okay, in the 1 mole of C3H8. And the same thing for carbon. There's 3 carbons, which is 36 grams. Each carbon is 12 grams, okay? So it's 18%. So, evaluating is 82% plus 18% is 100%. So simply, you just have to look at the formula, find the mass of each element present, and divide it by the molar mass of the compound. Then times it by 100. Okay, so here's a couple practice problems. Pause the video after each one and try it. Okay, so for the first one, calculate the percent composition of sodium carbonate. So here's the formula, Na2CO3. Find the total mass. There's 2 NAs, 2 moles of Na, 1 mole of carbon, 3 moles of oxygen. On the periodic table, how much does sodium weigh? How much does carbon weigh? How much does oxygen weigh? Okay. Now sodium, for example, is 23 grams. So 2 times 23 is 46 grams. Carbon is 12 grams. And there's only 1 of them. Oxygen, 16 grams. And there's 3 of them. Okay. Okay, So now, take a minute, figure out the answer, pause the video. Okay, so here we go. We have 46 grams for Na, 12 grams for carbon, 48 grams for oxygen. So the molar mass is 106 grams. Okay, so now we take our 46 grams for sodium divided by 106, our 12 grams divided by 106, our 48 grams divided by 106, and multiply each one by 100. Not 100%, by 100. Okay, in your book there's a percent sign. Don't get confused, it's by 100. Okay, so it's 43.4% sodium, 11.3% carbon, 45.3% oxygen. Okay. Okay, and if you add up the sum of each one of these, you should get 100. All right, let's look at the next problem. Calculate the percent composition of ethanol. Okay, C2H5OH. So there's actually 2 carbons, 6 hydrogens, 1 here, 5 here, and 1 oxygen. Calculate the molar mass. Okay. Pause the video. And then determine the percent for each one. Okay, so for this problem, let's take a look here. You should get 6 grams for hydrogen, 24 grams for oxygen, 16 grams for oxygen. So the molar mass is 46 grams. So 6 divided by the molar mass, 24 divided by molar mass, 16 divided by the molar mass. Multiply each one by 100 and you get 13%, 52.2%, and 34.8%. Okay, and you know you're correct when you add all these up and you get 100. Okay, last example. Calculate the percent composition of sodium oxalate. I'm not saying anything, just go ahead, calculate the percent composition of each one of these elements. Pause the video. Okay, so what we got here, same thing. You have 2 moles of Na, 2 moles of carbon, 4 moles of oxygen, times the mass of each one of them from the periodic table. Okay, and then here's the mass of sodium, mass of carbon, mass of oxygen. You take the sum of them, and you get the molar mass 134.0 grams. Then you calculate the percent composition. Take the mass of each element, divide it by the molar mass, times it by 100, and you get these percents right here. 34.3% for sodium, 17.9% for carbon, 47.8% for oxygen. And there is a sum of 100 here. Okay, so that's basically it. Now, there are some advanced problems dealing with percent composition, but nothing we're going to get into here in high school. In college, you will see a few more, but they're very simple. Okay. All right, guys. That's the end of this video. Have a nice day.